Welcome to my channel. In this video, we will discuss how to resolve a given force with respect to xy axis oriented about any angle or inclined plane, and we will also discuss about the oblique components. First, let us resolve the force with respect to an axis parallel and perpendicular to the horizontal plane. This is the horizontal plane. This is the inclined plane. The angle of inclination is theta. Let there be a box on the inclined plane and the force F acting on it. In this case, the x-axis will be parallel and y-axis will be perpendicular to the horizontal plane. The x component Fx is drawn parallel to x-axis and the y component Fy is drawn parallel to y-axis. Now the angle between the force and its x component be theta 2. Now Fx will be equal to F cos theta 2 as it is directed towards positive x-axis, and Fy will be equal to minus F sin theta 2 as it is directed towards negative y-axis, and the resultant force is equal to root of Fx square plus Fy square. Now let's resolve the force with respect to an axis parallel and perpendicular to the inclined plane. Again, this is the horizontal plane, this is the inclined plane. The angle of inclination is same theta. It is the same box on the inclined plane and the same force F acting on it. In this case, the x-axis will be parallel and y-axis will be perpendicular to the inclined plane. The x component Fx is drawn parallel to x-axis and y component Fy is drawn parallel to y-axis. Now the angle between the force and its x component be theta 3. Now Fx will be equal to F cos theta 3 positive as it is directed towards positive x-axis, and Fy is equal to minus F sin theta 3 as it is directed towards negative y-axis, and the resultant force is same. F is equal to root of Fx square plus Fy square. Now let's discuss some important points. Point number 1. Force can be resolved with respect to any mutually perpendicular axis oriented about any angle or inclined plane based on given problem. Number 2. The x component is drawn parallel to x-axis and y component is drawn parallel to y-axis under consideration. Number 3. To avoid confusion, always try to find the angle between the given force and the x component so that the adjacent side is always a cos component and opposite side is always the sin component. We can also find the angle between the given force and the y component. In that case, the opposite side will always be cos component and the adjacent side will be the sin component. But we have to stick to any one of the two ways to avoid confusion. Number 4. If the force F is directed parallel to the x-axis, then its y component will be equal to 0. Similarly, if it is directed parallel to the y-axis, then its x component will be equal to 0. Now let us discuss about the oblique components of a force. Let F1 and F2 be the two oblique components of a force. Let the angle between them be theta, and we know that for oblique components the angle between them is not 90 degrees. If we draw two parallel lines to the components, the resultant is represented by the diagonal OP. Let the angle between the resultant F and its component F1 be alpha. Let's draw one vertical line PQ and a horizontal line OQ. Let us take the free vector F2 here. The angle here is theta. The horizontal component of F2 will be F2 cos theta and its vertical component will be F2 sin theta. Consider the triangle POQ. In this triangle, F is the hypotenuse, F2 sin theta is the opposite side, and F1 plus F2 cos theta is the adjacent side. From the triangle, we get the resultant force F is equal to root of F1 plus F2 cos theta whole square plus F2 sin theta whole square. Expanding the terms and simplifying, we get F is equal to root of F1 square plus F2 square plus 2 F1 F2 cos theta. We can also find the angle alpha by taking tan alpha is equal to opposite side by adjacent side, which is equal to F2 sin theta by F1 plus F2 cos theta, or alpha is equal to tan inverse F2 sin theta by F1 plus F2 cos theta. We will discuss numerical problems based on these concepts in the coming videos. So thanks for watching. Have a nice day.